Welcome everyone to the September webinar of the webinar series Topics at the Nexus of Climate Change, Fisheries, and Blue Foods. My name is Laura Anderson. I support the Blue Food Futures program, which is one of the Ocean Decade programs behind this joint webinar series. This series is a collaboration among Blue Food Futures, FishSCORE, Supreme, SmartNet, FishMIP, and the endorsed project Becky. I'll be sharing a link in the chat so that you can learn more information about the different programs behind the webinar series. We're excited this month to be focusing on opportunities in aquaculture to support resilient and sustainable blue foods. We have two great presenters today. We're very grateful for them to share their insights with us. Our first presentation will be from Temiloluwa Akinyemi, and then we'll turn to a presentation by Rick Barrows. But I'll first introduce Temi. She works at the Monterey Bay Aquarium with the Global Ocean Conservation Team, working on research that advances the role of blue foods in addressing food and nutritional challenges. She's going to be presenting today on understanding the interplay between aquaculture, fisheries, and trade. And while our slides are coming up, I'll just remind folks, if you have any questions, feel free to put them in the Q&A box. We can be responding to them, and I can also read them out after the presentation. So feel free to put your questions in the chat. Temi, I'll turn it over to you.
Hi, everyone. Good morning. And thank you, Laura, for the introduction. Okay.
Is it showing?
It's showing, but it's showing with notes. So I think you have to change it to slideshow.
How is that?
Perfect. Thank you. Okay, yeah. Like Laura said, my name is Temiloluwa Akinyemi, but you can call me Temi, that's too long. And today I'll be speaking on the interplay among aquaculture, fisheries, and trade in Africa and how they impact food and nutritional security. Next slide, please. So when you talk about nutritional security, Africa is one of the continents in the world that is facing serious health issue due to inadequate intake of essential micronutrients like zinc, iron, vitamin A, to name a few. And in 2022, it was recorded, next slide, please. It was recorded that 257 million people are undernourished in Africa. Next slide, yeah. But studies have showed us that blue food can actually help us bridge these gaps because of its high nutrient density and relatively low environmental impact. Yeah, and this means that, as stated by Carter et al., blue foods are one of the few animal protein sources that can potentially help nations stay within the planetary boundaries while also improving their nutrition. Next slide. However, problems facing Africa, like overexploitation of fish, which has led to high import of fish, causing importing countries to be vulnerable to exporting countries' conditions like price fluctuation, like war, or even change of their mind. And also high export that has befell Africa recently has limited the potential of wild capture fisheries to bridge this nutritional gap. Next slide. So because of this, government, policymakers, stakeholders are looking into aquaculture as a solution to all these problems. Next slide, please. So with this in mind, my team and I decided to see how much aquaculture, fisheries, or even trade really contribute to not just food, but also to nutrient availability. And if the goal is to meet nutrient requirements through relatively low impact food, to what extent are African countries doing that, and how are they doing it? Next slide. So to answer these questions, I collected aquaculture and fisheries data from FAO, and then I used import and export data from aquatic resource trading species, and then I collected nutrient data containing calcium, protein, zinc, iron, vitamin A, and vitamin B12 from Aquatic Food Composition Database, and this was already aligned with the artist data based on the species. And then the population by demographics was taken from our wording data, and the RDA needed per demographic too was taken from US Department of Health and Human Services. This analysis was done for all the coastal countries in Africa and the countries surrounding Lake Victoria. Next slide. So from secondary data, we're able to calculate the micro and micronutrients needed for each country based on demographics from 1996 to 2019. And we also calculated the nutrients available for consumption based on the blue food available for each of these countries over the same time period. And this allows us to calculate the proportion of what is needed, the nutrients needed being met by blue food in Africa. Next slide. So to answer this question, to what extent are African countries meeting nutritional requirements through blue food, we choose to use 2019 as our reference to see the percentage recommended dietary allowance met through blue food in 2019. And this map shows a wide range, with Namibia meeting more than 100% of its protein needs through blue food, and Sudan and Eritrea only meeting 2%. So for this presentation, we chose to present our protein, but similar analyses were done for other micronutrients that I mentioned earlier. Next slide, please. So from there, we compare the recommended dietary allowance met, the percentage recommended dietary allowance met in 1919 with the percentage recommended dietary allowance met in 2019 to determine whether there has been an increase or there has been a decrease, as shown in the third panel. So the first and second panel allow us to see the factors that contribute to the decline or increase in the ability of the countries to meet their percentage RDA through blue food. And when you look at the first panel, for example, Namibia, for net fisheries and aquaculture, for Namibia, the net fisheries for Namibia, Senegal, South Africa, Morocco shows that it has been declining between 1996 and 2019. And when you look at the second panel, you see that the net trade shows exports for these countries to be increasing. And then when you look at Gabon and Ghana and and Cape Verde, you see that their import has been increasing more than their export. But when you come down to the third panel, you could see that Namibia, Senegal, South Africa, Morocco, who has been increasing their export and has been experiencing decline in fisheries, have also been experiencing decline in their ability to meet the RDA through blue food. So coming down to, and despite the fact that Ghana, Gabon, and Cape Verde are increasing their import, despite the fact that they are doing that, their fisheries have been declining and their percentage RDI met between 1996 and 2019 has also been declining. So their import has not been compensating for their decline in fisheries. And so when you come down to countries that are increasing their percentage RDI between 1996 and 2019, you see Sudan down to Mauritius. And it is shown that majority of this country are doing so, they are increasing their percentage RDI through import, while some of them are combining fisheries and aquaculture, like you see in Nigeria and Uganda, to increase their percentage RDI. Some of them are combining only fisheries and import, as you see example in Guinea and Mauritius. So because of things happening with countries, we could see that there are different things happening in different countries. We decided to run a PCA, which is the principal component analysis. Next slide, please. Yeah. So we decided to run a principal component analysis to define typologies that we see in these countries. So for the first typology we saw, the countries in red are countries that are increasing their import and aquaculture for their nutrient production and nutrient availability. And the second typology we saw are countries in blue, and these countries increases their import to be able to have nutrient production through blue food. And the third country, we saw countries in orange, and these countries increase their import and fisheries, both import and fisheries, for their nutrient availability, for their nutrient production through blue foods. And the last country that we saw from this typology are countries with increased export. And majority of these countries are also experiencing decline in their fisheries. So from this typology, we chose one country each from this typology to be able to explain what is really going on, what is the trend, how does it look like? So for the first one, next slide, please. So for the first typology, we saw countries that are reliant on import and aquaculture for their nutrient production and for their nutrient availability. And the example we chose is Kenya. And looking at the graph, we have two graphs. We have for protein and we have for calcium. And both start from 0, which means that all the years are relative to 1996. So 1997 minus 1996 down to 2020 minus 1996. So as we see here, we saw that fisheries is in green, aquaculture is in blue, import is in red, and export is in purple. So when you see export on the positive side, it shows us that export is decreasing. But when you see it on the negative side, as it's shown in 2002 for protein, then it means that it is increasing. So compared to 1996, export increased in 2002. So we did this because export is what is being taken out of the country, not what is being added to the country. So looking at the graph, so fisheries that produces protein for Kenya has been declining compared to 1996. And aquaculture and imports that produces protein for Kenya has been increasing compared to 1996. Yeah, and then when you come down to calcium, you could see that relative to 1996 also, fisheries that produces calcium for Kenya has been on the decline. And import that produces calcium for Kenya has been increasing, but it has not been able to offset what is happening in fish. It has not been able to offset the decline that we see in fisheries. And when you look at the two graphs, you can see that aquaculture supports protein. It's contributing a little to protein, but when it comes to calcium, another micronutrient that we looked into, aquaculture is not contributing as much to those micronutrients in Kenya and other countries that are under this typology. Next slide, please. So for the second typology, we saw countries that are reliant on import. An example is in Cote d'Ivoire. And this country, relative to 1996, we could see it was obvious that these countries depend so much on imports. As relative to 1996, they've been increasing their import, and their fisheries has also been increasing relative to 1996, but it's very, very small. Its contribution is very small compared to the contribution of import. And when you come to the other micronutrient too, example, we chose zinc for Cote d'Ivoire, and we see that fisheries that produces zinc has been declining, and import has been increasing for zinc. So this tells us that despite the fact that their fisheries is small, there's still need for their fisheries to be managed. So the third typology, next slide, please. The third typology, we saw countries that are reliant on import and fisheries, both import and fisheries, for their nutrient availability and for their nutrient production. And as I said earlier, all is relative to 1996. So compared to 1996, fisheries and import has been increasing for both protein and other micronutrients that we looked into. And as you see, in some years, fisheries increase while imports decline, and in some years, imports increase while fisheries decline. But the message here is that both import and fisheries has been increasing relative to 1996, and their contribution is showing for these countries. Next slide, please. So the last typology we saw from the PCA are countries with declining fisheries and increasing export. And the example we chose Senegal. And as you see from the graph, relative to 1996, from 1998, fisheries has been on the steady decline. Fisheries that produces protein and other micronutrients in these countries have been on a steady decline. And also export has been increasing on a steady increase for this country. So this means that nutrients that is being produced from fisheries are being exported out of the country. So countries don't have it retained in their country. Next slide, please. So the last country that we saw was Egypt. And like I mentioned earlier, from the three panels, we saw that Egypt is the only one using aquaculture to increase its RDA between 1996 and 2019. So we do not include Egypt in our PCA because of that, because it was obvious that they are aquaculture dependent. So looking at Egypt, we saw that relative to 1996, aquaculture and import has been on a steady increase, especially aquaculture and import that produces protein for Egypt. But when you look at fisheries, you can see that the fisheries that produces protein has been declining for Egypt. And aquaculture is contributing more than even what import is contributing when it comes to production of protein for Egypt. But when you come down to micronutrients, example we chose vitamin A, you could see that the contribution of aquaculture in vitamin A is not as much as it is in protein. And when you look at the fisheries, you could see that fisheries is helping to maintain their vitamin A production through bluefoot. And aquaculture contribution is more in vitamin A. Sorry, imports contribution is more in vitamin A than it is in protein for Egypt. Next slide, please. So now marrying the percentage recommended dietary allowance for protein in 2019 with the contribution of each source, it shows us how much aquaculture, fisheries, and import actually contributes to countries meeting their nutrient needs through bluefoot. And this is how it looks like holistically, but for easy viewing, I section it into regions. Next slide, please. So for North Africa, we have Egypt meeting 32% of its protein needs, the RDA for protein through bluefoot, and this is coming mostly from aquaculture with support from import and fisheries. And when you look at Libya, you can see that Libya meets 23% of its RDA for protein through bluefoot, but that comes mostly from imports with little support from fisheries. And Tunisia combines the three, combines fisheries, aquaculture, and also imports. But aquaculture contribution is not as much as the other two contribution to their nutrient needs through bluefoot. And looking at Morocco and Algeria, these two countries, they meet their recommended dietary allowance mainly through fisheries, but meets only 12% and 4% of that. And this is showing for protein. Like I mentioned earlier, similar analysis was done for other micronutrients. For the purpose of this presentation, I'm focusing on protein and in 2019. Next slide, please. So coming down to West Africa, you could see that there are two distinct things going on here. So from Mauritania down to Liberia, removing Cape Verde, you could see that this country depends solely on fisheries to meet their recommended dietary allowance for protein through bluefoot. But it's only Sierra Leone, Guinea, and Gambia that meet more than 20% of their RDA for protein through bluefoot. And when you come down to what we can say Gulf of Guinea in West Africa, so from Cote d'Ivoire down to Cameroon, you could see that that's the Cameroon. You could see that these countries depend on import. Although Cameroon combines imports and fisheries to meet 24% of its RDA through bluefoot. And also Cote d'Ivoire, Benin, Ghana, they meet more than 20%. We can see Cote d'Ivoire meeting 35% of its RDA for protein through bluefoot, and that mostly comes from import. So when you come down to the Central Africa, Gabon, and Congo, we see that these guys are meeting almost 40% of their RDA for protein through bluefoot, and that mostly comes from the combination of imports and fisheries, but mostly imports. Next slide, please. And then looking at East Africa, combining Sudan, we saw that these countries, when it comes to meeting their RDA through bluefoot, they are not meeting up to 10% of it. But looking at, it's only Uganda that is meeting 20% of their RDA through bluefoot, and that comes mostly from fisheries with a little support from aquaculture, and minute support from import. And Seychelles meets more than 100% of its RDA for protein through bluefoot, and that comes mostly, like it looks like everything comes from import with little support from fisheries. And the next slide please. And the Southern Africa with part of Eastern Africa, we saw Angola, Namibia, South Africa meeting, Namibia meeting more than 100% of its RDA for protein, also through bluefoot, and Angola and South Africa meeting 80% of its RDA, 80% and 9% of their RDA true blue food, and that mainly comes from fisheries, apart from South Africa that makes fisheries and import. It looks like it's 50-50 in South Africa. And looking at Mauritius, we saw that Mauritius means 54% of it are the true importation of fish, and little support from fisheries as well. Next slide, please. So looking at all the results, looking at the figures, looking at the graphs, you could see that ability of aquaculture to actually offset declining fishes production is limited, as Egypt is seen to be the only one that aquaculture is really helping with both protein and other micronutrients. And this also, we can say that it's because the fishes is even relatively small. And while aquaculture can supplement protein intake, its contribution to non-protein nutrients is even more limited. When you look at the pictures that I have on the right, the first picture shows how aquaculture is done in Egypt. And the second picture shows how aquaculture is done in other parts of the countries in Africa that are into aquaculture. And these countries are solely dependent on only tilapia and catfish. So you could see why aquaculture produces more of protein and leaves other non-protein out. So it's difficult to say that tilapia should be substituted for small pelagics that can produce all nutrients that we need in Africa. And also we could see from the result also that trade can either be a supplement or a sink for nutrients. Especially for countries that are export oriented, trade can be a sink because it takes out all the nutrients that you need in the country. And for countries that are dependent on import, there's a need for them to consider its impact on their food security and also nutritional security. So from the take home, next slide, please. So from the take home, we could say that given that aquaculture might be meeting protein needs, but it's not meeting other nutrient needs, then all African countries, including Egypt, needs to implement effective fisheries management. And there's a need to continue to develop sustainable aquaculture options that do not undermine local fish stock. And also, to meet the full range of necessary nutrients, there's a need to explore broader species mix for aquaculture. So there's a need not to shift away from tilapia and catfish, but there should be added species to the culture of aquaculture and culture of fish. And the last recommendation I have here is that there's a need to develop a balanced trade policy, especially for countries that are export oriented. There's a need for them to develop a trade policy that prioritizes the retention of nutrient-rich species for domestic consumption. This recommendation is broad, and our next step will be to develop a policy brief with recommendations specific for each country. Next slide, please. So with this, I would like to acknowledge my team who double as my boss, my supervisors, my mentors, my everything. Thank you for doing this with me. And yeah, thank you everyone for your time and interest in sustainable food and nutrients for African countries and for listening to this. You can contact me with these details and I'll take questions. Thank you.
Thank you so much, Temi, for your presentation. We have a few minutes if folks have questions for Temi about her presentation, and then thank you for sharing your contact information. One that I'll read that came from the chat from Coralie is, where do the West African countries import blue foods from? I'm curious if you sort of know that.
Yeah, most of them, especially Nigeria, Nigeria imports stockfish from Norway, and some of them Cote d'Ivoire imports tilapia from China, from Asia countries. Some of them import small pelagics also from Mauritania, which is in West Africa also, and some imports from Namibia, so. Have I answered the question?
Right, if there are any other questions, feel free to put them in the chat, and we can also sort of after the second presentation answer questions about both presentations too. Well, thank you so much, Temi. And I'll turn things to our second presentation today. which will be shared by Rick Barrows, who's the founder of Aquatic Feed Technologies and who also serves as the Chief Scientific Officer of the Future of Fish Feed and Feed Innovation Network, a marine conservation organization focusing on the development of aquaculture feeds that do not rely on marine harvested ingredients. So Rick will be presenting about the Future of Fish Feed, or F3 effort today, and Rick, I'll let you take it away.
Yeah, that's slide number 3. Could we back up to the first slide, please? There we go. Thank you very much. I appreciate the opportunity to speak about the F3 program. This is a collaborative network of people spread throughout the U.S. and overseas with the goal to spur the innovation and commercialization of aqua feeds that do not depend on marine harvested ingredients. And the names listed here, myself, Kevin Fitzsimmons, Michael Tlusty, Ling Chow, and Ewan McLean, those are the names you'll see on our journal articles that we publish and on slides for presentations like this. But there's a whole host of other people that make the F3 program really work and stay focused. And I'll go into more of the organization in a minute, but first I want to talk about briefly why we're all working together on this goal. Next slide, please. You're all probably aware that sardines, anchovies that should be being sent to Africa are being have for over 100 years have been harvested for industrial uses, ground into fish meal. And in the 1960s, most of that fish meal was going to the chicken and pig industry. Aquaculture used very little, but that's when the salmon industry started in Norway. Aquaculture was using increasing amount. Then aquaculture has been growing very quickly. It's the fastest growing sector in agriculture, and aquaculture is now producing more than 50% of the seafood globally. And so this creates two reasons for our focus. The first is that if aquaculture is going to continue to supply more nutrients for human consumption, if you're reliant upon a static fish meal and fish oil supply, and it's static at best, most of the forage fisheries are either at or above maximum sustainable harvest, then you're going to limit the expansion of aquaculture if you have to depend on that. But more importantly, maybe we shouldn't be at maximum harvest of sardines and anchovies for this use. When it could go to better uses or remain in the ocean and a more balanced ecosystem. Next slide, please. So the F3 program is part of the Anthropocene Institute that has two main focus areas. The first is marine conservation, and the second is energy production, where they're doing some very neat things, but I'm not qualified to talk on that. But within marine conservation, there's the Marine Protected Areas program, and you can find more information on that at protectedseas.net. That can lead you to the Navigator map, which is pretty cool. It's a software program that shows all the marine protected areas around the globe. You can click on that and get all the regulations that apply to that particular marine protected area. And law enforcement has really been utilizing it a lot because there's so many overlapping regulations in certain areas. They've also developed a marine monitor program for these marine protected areas using radar and drone technology that when a ship enters the marine protected area, the drone goes up, records when they entered and when they left. And I believe now there's been 3 successful prosecutions using this technology in 3 different countries, successful prosecutions, 3 different countries. But the Future of Fish Feed program began in 2015, and more information on that's available at f3fin.org and also f3meeting.com, and I'll go into more of that in just a moment. Next slide, please. And I'll jump right to the end that to back up a little bit, when aquaculture was expanding, it became apparent that if you just put a whole lot of that fish meal into the aquaculture feed, fish meal carries with it so many nutrients that that's pretty much all you had to do was add vitamins, minerals, and fish meal and some oil and a binder, and then you have a complete fish feed. But we've been able to remove fish meal, krill meal, fish oil, marine harvested ingredients from carnivorous species as well as omnivorous and of course herbivorous species, because fish require the nutrients, not the ingredients. We've gone through all those ingredients and figure out what nutrients they're carrying with it. And for trout, for example, a plant-based feed might have 20, 24 ingredients, where in a fish meal-based feed, you've only got 12 because of all the nutrients that it's carrying with it. So as a group, we're talking about what are the factors affecting adoption of alternative feeds, or the lack of adoption of alternative feeds. And we came up with a three-pronged approach. Next slide, please. Which involves contests or challenges, providing an incentive to try to get out of the comfort zone and try some of these alternative feeds, and also education through meetings and webinars, and research and F3 Fin, or Feed Innovation Network, which is also part of education. But next slide, please. The first challenge was the Fish Free Challenge. That started in 2015. And this was the award. The winner of the contest would be the company that produced the most feed without using marine ingredients. And we had all these participants. Next, please. And the winner was Evergreen Guangdong in China. Next slide, please. They produced the most, and they got a $200,000 check. And when I joined in 2016, I said, well, I think tilapia is probably going to win if it's open to any species. And sure enough, tilapia did win. But when we got to visit China after the challenge, we found that they had been feeding high levels of fish meal and land animal proteins. And when they took those out, not only did the fish do better, grow faster, the water quality in the ponds was better. So we really reached the objective that we were looking for, even though that was tilapia. Next slide, please. So there are lots of different protein sources we can use to provide the protein in a fish diet that fish meal provides. But there were very limited things that we could use to replace fish oil, basically just marine algae. And there were several products on the market at the time. These were whole cell products, Schizoscytrium variety, heterotrophic. You feed it sugar, it produces those long chain polyunsaturated fatty acids that are required for fish health and human health. But there was a large variation between sources of algae in the digestibility, that the amount of oil that would be available to the fish that eats it. Next, please. And the winner was Veramaris, because they developed, because they sold the most fish oil replacement, but they developed a method to extract the oil from the algae. And so they're selling a liquid rather than a dry powder. And this has been accepted by the salmon industry worldwide, and it's going very well. And yep, next slide. That was a $200,000 prize as well. Next slide. The third challenge, we returned to the feeds, but this time focusing on carnivores, and it was the carnivore challenge. And there were three categories: salmonids, shrimp, and other carnivorous species. Next. And we were happy to get all the participation that we did. We had winners in each category, and an honorable mention in the other carnivorous species. These are marine species. Next. And there were $100,000 award in each of those three categories, and it garnered a lot of interest. Next slide, please. So one of the things we were getting pushback on was that if we were told by feed manufacturers, and particularly fish farmers, particularly old fish farmers, that if you take all the fish meal and fish oil out of a feed, then their animals will not eat it because it doesn't smell fishy. Well, they've been using krill for that as a palatability enhancer. And also a lot of krill is used in feeds, medicated feeds, where you have to cover up a bad taste. And this is a very fragile fishery down in the Antarctic. And if we could find a replacement for krill, then that might take the pressure off the krill fishery down in the Antarctic. And we were going to be happy if we just had 3 entrants, but we actually had 39 entrants. But before we could do this challenge, we contracted with a facility down in Chile to run an experiment to develop the methodology to determine if these additives or feed ingredients were a direct replacement for krill. We had a series of fish meal-based diets and plant-based diets. When you add krill to a fish meal-based diet, we saw no improvement in growth, feed intake, or survival. But adding krill to a plant-based diet for Atlantic salmon, we got a very strong response. So we had our methodology for the challenge. But with 39 entrants, the judges had to go through, next please, and pick out 10 different ingredients. We had everything from protein hydrolysates to algae to single cell proteins. There were 2 insect proteins in there, a fungus, a wide variety of ingredients. Next, the 2 winners were protein hydrolysates, and next we had 3 runners up that were very close and show a lot of promise. So this is successful, showing that Atlantic salmon or other species don't require krill, that there are commercially available scalable ingredients that can replace krill in a plant-based diet. Next, please. So the 5th challenge is the Fish Farm Challenge, and this is just open for registration last week. And here we're going to focus on the farm, the fish farm, and the winner will be whoever sells the most fish fillets or fish meat fed only non-marine feeds. And there are 2 contests that will be run simultaneously, the 2-year contest from 2025 to 2027, the 4-year contest from 2025 to 2029. Each of those will be, the winner of those will be a $90,000 prize with $10,000 special award to a salmon producer in either of those categories. And more information on this can be found at farm.f3challenge.org. Next, please. The second prong of our 3-prong approach is meetings and webinars. Next, please. With each of the challenge, we've held an in-person meeting in San Francisco to support that challenge with all the participants invited, of course, along with feed manufacturers, feed ingredient suppliers, seafood distributors, and venture capitalists. And we've been able to put together through those meetings several partnerships where venture capitalists have found exciting new young companies and been able to invest. But then in 2020, when the pandemic hit, we couldn't hold meetings for a while. So we started a series of webinars, and those are all available on our website. Several of them were focused on Asia. That's why we had so many attendees. But next slide, please. And then on research, I mentioned FIN, F3 FIN, that's the Feed Innovation Network. Next. We've done demonstration or contracted research with the list of different species here, including Atlantic salmon, Pacific white-legged shrimp, largemouth bass, red drum, Kampachi, et cetera, And with Pacific white-legged shrimp, they're now being commercially produced in Vietnam, so that has been commercialized. We did this as a demonstration, but also to produce publications and trade publications as well. Next slide, please. These are the current projects that we have ongoing. They're either ongoing or they're planned in the immediate future. Now that we've shown we can get rid of fish meal, fish oil, and krill, more people are asking, well, let's get rid of land animal proteins. So we're working with Red Drum and Texas A&M University, Atlantic salmon with Superior Fresh Salmon here in the U.S., and hybrid striped bass also at Texas A&M. We're working with rainbow trout with the University of Idaho to further develop methods to determine the previous diet history of fish. That is, to see if that fish really has not been fed any marine proteins or vice versa. And I might add, when I start talking about plant-based diets for carnivorous fish, we got a lot of pushback from different groups saying that we're trying to turn lions into lambs by feeding them plant-based diets. And we're really not changing the animal at all, but we're trying to turn soybeans, corn, and wheat into meat by adding all those extra nutrients such as amino acids, trace minerals, et cetera, et cetera. Next slide, please. So part of the networking or education component of F3, we developed this website, the Feed Innovation Network, where we're making available lists of things like F3 ingredient suppliers, some innovative new ingredients. How do you find them? And there's contact information. There's also F3 feed suppliers, or list of fish farms that are producing fish, fed only marine-free diets, marine-free harvested diets, sustainable retailers. And then there's also, on the next tab to the right there of the F3 suppliers, is the open formulas. These are formulas that have been proven to be effective for a variety of different species, that any user can use that and modify it to fit their own needs. That's why it's considered an open formula versus a closed formula. And we also have received comments that these diets are too expensive. And yes, any innovative approach is going to be more expensive than the previous commercial approach, whether it's a object or a ingredient. But that's what industry needs to do, is to figure out what's most cost effective, and they are very good at doing that. So we're not trying to say that these diets are the only way to do it and it's the most cost effective way. There's still room and need for a lot of innovation. Next slide, please. We also saw that a lot of these new ingredient suppliers and some very innovative ingredients weren't aware of what types of experiments need to be conducted with your ingredient prior to going to a feed manufacturer. Nothing makes a feed manufacturer more upset than not have that information when you knock on their door. So under evaluation, we've got ingredient evaluation that has the 6 types of experiments that would be good to do, feed evaluation, how to do that, different testing facilities that could test your ingredients. And it's hard to get small batches of feed produced, so there's certain places that can do that. We list that as well. And the one thing about F3 project and the Anthropocene Institute is they're very supportive of all of us within the project, working with industry and the general public in some of these new innovations. So if there's anything we can do to help, please reach out and let us know. Next slide, please. Thank you. The email's down below.